Imagine that you've just recently put up a business. Let's say a chocolate manufacturing company. All is well. You have your resources, machines, and workers in good condition. And yes, you are more than ready to jumpstart. Now, as the business owner, you want to earn more, and so you think of producing more outputs. Why not? Isn't that the case? The more you produce, the more you earn. So now you produce more and more and more boxes of chocolate. However, sometimes later, you viewed your company's financial statement and found out that you've had loss instead of profit. You ask, what have possibly gone wrong? Is someone stealing, or do the outputs you produce still inadequate? Until you've done your research and found out that producing more output does not immediately equate to more profit. Because as you produce more, you also incur more costs. The question is, how do you produce efficiently? And this is when differential calculus comes into picture. But first things first, what is differential calculus?
According to Russell 2020, differential calculus deals with the rate of change of a function. Now, this rate of change is measured using a quantity known as derivative. The derivative of a function, according to Matthews et al. 2013, is basically the slope of the line tangent to a particular point on the curve, denoted by dy over dx or y prime. So now, how does it become related to optimizing your profit and cost? As we express cost and profit into differential functions, it becomes possible to use differential calculus to find the profit and cost of functions' maximum and minimum points respectively. These points tell us when, that is at how much output the profit is the highest and when the cost is the lowest. Graphically, we say that your output is the independent variable and your profit or cost is your dependent variable. Here, we want to find the number or value of output that will give the business the maximum profit and the minimum cost.
As an example, let's go back to the chocolate manufacturing company. Suppose that their profit is denoted by this function, where x is the number of output. To get the number of output that will give us the maximum profit, we get the first derivative of the profit function and equate it to 0. That is because at maximum or minimum point, the slope will be 0. Now, doing algebraic operations, we found out that x is the number of output that might give us the maximum profit of 128. However, be careful, because we are not sure yet whether x or the number of output we get really a maximum point, since it could also be a minimum point. That is because we know that the slope at maximum or minimum points are both equal to 0. To know that, we can use the second derivative test. But how does that test work?
As the name suggests, we get the second derivative of the function and input the value of x or the number of output. If the answer is negative, it means that the function is maximum at x, while when it is positive, the function is minimum at x. Going back to the example, recall that the profit function is this. Getting its second derivative, we have. Inputting the value of x, we have. Thus it only confirms that x is equals to 128, the function is at maximum. Now, what does this mean? It only implies that the company should produce 128 outputs to earn a maximum profit. To know how much the maximum profit will be, we can simply input the value of x into the profit function that gives us 30,041 pesos and 7 cents. Similarly, we use almost the same process in minimizing the cost. The only difference is that we have to get a positive number in the second derivative test to ensure that the number of output will result to a minimum cost.
Finally, we found out how powerful differential calculus is in optimizing profit and cost. The truth is, it is only one of its many applications. In fact, its uses ranges from medical sciences, engineering, and even up to graphics designs. Therefore, calculus in general is not only a mere theory, but also a powerful tool in the advancement and innovation of the humanity.